are going to be reviewing how to partition a line segment. This is a common question on the Geometry Regents exam. So let's get to it. All right, question number 1. In the diagram below, segment AC has endpoints with coordinates A, -5, 2, and C, 4, -10. If B is a point on AC and AB to BC is equal to 1 to 2, what are the coordinates of B? Okay, the first thing I like to do in a problem such as this is separate the two parts in the ratio, right? We have AB and BC. This is something I teach as early in geometry, where the AB is getting the 1 and the BC is getting the 2. The order is very important. And I usually connect an X because a 1 to 2 ratio means that if we multiply 1 by any unknown number and we multiply 2 by the same number, we're still going to be in a 1 to 2 ratio. But this also helps me know that what I really need to do is to add those together, 1x plus 2x, and that gives me 3x. So it also tells me that what I need to do is divide AC into 3 equal parts, and then it would be easy to stick a 1 and a 2 into those parts. All right, let's get to work. Well, my graphic solution goes something like this. I like to take any diagonal line and kind of convert it into a right triangle. It makes it really easy to count both the horizontal and the vertical. All right, so once I have my triangle drawn, I go to the horizontal. I could actually go to the vertical either, but I go to the horizontal and I count quite simply. 1, 2, 3, 4, 5, 6, 7, 8, 9. Right? There's 9 units in the horizontal between A and C. So if I went back to my 3x here and I said, well, 3x needs to be equal to 9 and solve this equation, I find out that my x is equal to 3. Well, if x is equal to 3, that means each part will be 3 units long. So I quite simply, I'm going to go back to my first point here, and I'm going to count every 3 units and put another point. 1, 2, 3. 1, 2, 3. So as you can see, I've now divided my horizontal into thirds. And from each one of those, I'm going to draw an arrow straight up and see where it hits my line segment. And now I'm going to put points on those locations. There's 1 and there's 2. So now, just by using the horizontal and dividing that into thirds, I was able to quite easily divide segment AC into thirds. Now, going back to my problem, I see that AB, the distance from AB, the B, a point which I've yet to put on this graph, is only 1 unit from A, and B to C is 2 units. If I have 1, 2, 3 units, that means here is 1 unit from A, and that's going to be my B. So you could see that this kind of is my 1x distance, and B to C is my 2x distance. I don't even need to know exactly what that distance is in this problem to already have my answer. So point B, as you could see, is -2, -2. Answer number 1. Let's do another couple of problems here. Okay, here's one that was on a multiple choice from a Regents that did not have a graph. But on a Regents exam, you do have scrap graph paper. So you take out your graph paper and create a set of axes. And there's no reason why you can't do this problem the same exact way we did the other problem. But we're going to start from scratch this time. Here it says, what are the coordinates of point C on a directed on the directed segment from A, -8, 4, to B, 10, -2, that partitions the segment such that AC to CB is 2 to 1. Okay? If we started out the same way, well, actually, I'm going to do something first here. I am actually going to plot those points. So I got A, which is -8, +4, right there. And I have B, which is 10, -2. I'm going to label that. This is A. Here is B. I'm going to connect them with my straight edge. And in exactly the same way as earlier, I'm going to create my right triangle. It's very helpful hint there, that right triangle. All right, I'm going to go down to there and then across. And there's my right triangle. Okay, so to be consistent with what I did in the first problem, I'm going to take out my AC and my CB. I'm going to put a 2 on the top because that AC is the first part, at which the 2 corresponds to that, and the 1 on the bottom. And I'm going to connect an X. And once again, when I add them, I get 3X is equal to, well, let's go count. I'm going to use my horizontal. So I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. Going to put that there. And of course, when we divide by 3 to solve for X, we get 6, meaning every 6 units will be a third in this case. So I'm going to go down here and start at 0. 1, 2, 3, 4, 5, 6. Put a point. 1, 2, 3, 4, 5, 6. And then, of course, 1, 2, 3, 4, 5, 6 gets you back to B. And again, I'm going to take my straight edge. I'm going to go straight up from each one of those until I hit my line segment right there and right there. I'm going to put points in all of those spots right there, right there. But this time, it said that AC, the distance from A to C, should be the 2 units, and the C to the B should be the 1 unit. So that means that my C is going to be right here this time. And what points is that? 4, 0. And there you have another graphic solution to the partitioning of line segments. Let's try another one. Okay, here's a good one. This one is interesting because it was, again, a multiple choice question, but almost intentionally giving you a large number. Well, here, I'm just going to use all my graph paper. I had to make mine a little smaller to fit. And on the graph paper, I'm going to create a set of axes, knowing that I'm going to have to fit as high as 20. So it's 5, 10, 15, 20. So I'm going to go down, say, to the here, and then go across, say, from here. So there's my set of axes that I've created. Okay, now I am going to graph the points. And R is -4, 5. And W is 6, 20. 5, 10, 15, 20, right there. And that's my W. I'm going to connect them. Oops, I moved the point. And once again, I'm going to create my right triangle. Okay, there's my right triangle. And now I'm going to create my little table over here on the side. I got R, P, and P, W. The RP is going to get the 2, and the PW is going to get the 3. And I'm going to put an X next to each one. We're going to add them up and get 5X is equal to, and now I'm going to count. I got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 is equal to 10, which means each unit will be equal to 2 boxes. So I'm going to put a point every 2. 1, 2, 1, 2, 1, 2, and 1, 2, and then the end. So as you can see, I've now divided the horizontal into 5 equal parts, meaning fifths. And now from each one of those, I am going to go up and meet my line segment. This one's right on the axis. That one's right there. That's my third. And there's my fourth. Okay, now where are we going to place point P? Well, P is 2 units from R, right? RP is 2x. So I'm just going to go from R. I'm going to count 2 units, 1, 2, and I'm going to put a point right, I think that meant right there. And as we can see, that point where I'm going to put my P is 0, 11. 0, 11. Number 2. And there you have it. I hope that was useful. And if it was, you can subscribe to Mr. Frank's YouTube channel.